All right. Are you through with this? Okay, if you're not seeing it, let me just repeat it. On the board, I think this one is more visible. The two types of isomerism is what? Structural and stereo. Under the structural isomerism, there are three types. Though we have two more types, but just that for this your level. The three main structural isomerisms are chains, positional, and what? Functional isomerism. Okay. The stereo isomerism is of two branch. One is what? Geometric and what? Optical. In chain isomerism, the molecules, that is the compounds, have the following. Sometimes this following will be A, B, option A, option B, option D, option C, and option D. They will come as options. In chain isomerism, which of the following? In chain isomerism, they will say which of the following best describe chain isomerism. In chain, you will see that the molecules will have the same functional group. That means for molecules to be described as chain isomers, they must belong to the same function. They must have the same functional group. They must belong to the same homologous series. They must have the same molecular formula. They must have different chains or different structural formula. So these are features of chain isomers. For instance, for example, I'll just give one example. I go to the next one because I know why I didn't want to clean this. Exam is less than 2 months. Okay? It's less than, let's say remove 13 days. Let's say exam is now what? 1 month. 13 days is just like approximately 1 month. So examples or example is C4H10. C4H10 will tend to form how many isomeric compound? 2. And you find that the two isomers are chain isomer because one of the features of chain isomer is that they will have different chains. Maybe one will be straight chain, the other ones will be what? Branched. When they were one branched, when they were two branched, when they were many branches. But mind you, a chain isomers are one that has one straight chain and other branch chain. That's why the name is chain. The isomers have different chains. Any isomer that have different chains are chain isomer. But there are some isomers that will have the same chain. Those ones are not referred to as chain. Maybe they probably may be positional or functional. Do you get the point now? For instance, this organic compound will form 2 chain isomers. One is 1, 2, 3, 4. That one is what? 1, 2, 3. And then the fourth one will be somewhere here. So the phenomenon here. Okay, that is it for chain isomer. Then, for positional isomer, are you there? Are you here now? Please come to this side. Please write positional isomerism as subheading. I'm done with this one last time. I just recap. It should be fast now. It should be fast. No time. 1 month to go. 1 month to go. Okay. Under positional isomer, are we there? Right, positional isomerism. Idegia. Okay. Now you write. In positional isomerism, comma, in positional isomerism, comma, the isomers, I can't shout, so this thing I change. The isomers, the isomers have the same molecular formula. The isomers have the same molecular formula. The isomers have the same molecular formula with different structural formula. With different structural formula. With different structural formula due to possession of functional group. Due to presence, please write it that way. Due to presence of functional group. Due to presence of functional group in different carbon skeleton. Due to presence of functional group in different carbon what? Skeleton. Full stop. Example. How many structural isomer? A question. That's the example. How many structural isomer? How many structural isomer are there? How many structural isomer are there? In an organic compound? In an organic compound of molecular formula. In an organic compound of molecular formula, C3, in an organic compound of molecular formula, C3, H6, Br2. C3 on the board, is on the board, on your screen. C3, H6, Br2. Answer is what? Answer is what? The answer is what? 4. Then I want 4 kita on the correct. But I don't know why. Your answer is 4. Is it by guesswork? What? Is it by guesswork? Or by have seen it in past question before? And then the answer is 4. Are you like, okay, I've seen this before. This is 4. Well, you know, I say, how many structural isomer are there? In this isomer, chain remains the same. Do you know what I mean by chain? It's not changing chain like this one. This one is 4 here. This one is what? 3 here. Understand? 3 long chain here with a branch. This one is what? Only straight chain, no branch. This one is on branch. This one is what? Branch and there on branch. Do you get the point now? So that's how to know molecules or structures that are chain. But you see molecules that have the same chain, no branch, they are all unbranched. Only that the functional group are on different carbon chain. For example, now, the functional group of this molecule is what? Who can tell me the functional group here is what? Bromine. Is what? Bromine. Cast your mind back when we did functional group. I think I told you bromine is a halide. Okay? The functional group for halides is what? X. Halides. X. Bromine is a halide. So this is what? Dibromo what? Propane. It's not true. Dibromo what? Propane. Is it not propane? Propan is 3. Prop is 3. Pan is that all the bond in the carbon long chain is what? Single bond. So it is a propane. A propane halide. So you can still call it propyl bromide. Sure, you know. which is what? Dibromo what? Propane. Question now asks you, how many possible isomer, how many possible structural isomer are there in this organic compound? What you will do is to draw the carbon chain. How many carbon chain will be there? 3. 1, 2, 3. Finish. Put bromine in each of them. Make sure the 2 bromine are in different chains of the carbon. It starts with having the 2 bromine somewhere here as Br and what? Br. You do this until there is no possibility of rearranging the bromine. Bromine is here in the first carbon atom. I'm talking now. I'm talking. Eh? I'm talking. Once I'm done, you give it to me. I'm coming. The median. Okay, now as I was saying, this is the first one. Then you draw another one. Make sure you don't change the chain. The chain will still remain what? 3. Don't do cut and join. Like this one, you know, we'll do cut and join. That is why it is chain. But this one is on chain. On chain. So it means that the chain still remains 1, 2, 3. The only thing that will change here is the bromine. That is that definition you see there. That the only thing that will change is the what? Is the functional what? Group. Since you now recognize bromine as functional group, now you can now say, okay, since here we have bromine, here you can have what? Bromine and what? Bromine. The 2 structures are the same molecularly, but in terms of structure, they are not what? The same. So that is what makes it a structural what? Isomer. But which type is this? Is it chain or position? Position. Position has changed. Chain remains what? The same. The next one is, since we have this, the next one is what? 1, 2, 3. Since we have had bromine here, I can shift this one to be what? To be here. The structure had changed, but the chain remains what? The same. Then, I've got 1, 1. This middle one is what? 1, 2. This is what? 1, 3. Who can tell me other one we can? So 2, 2 will now come in. 1, 2, 3. Maybe here is what? Br and what? Br. And I have something like this. This is how many isomers now? 1, 2, 3, 4. What if I have this? 1, 2, 3. I have bromine here, bromine here. What name is the same thing with this up here? So I think at this point we cannot have more than this as possible isomer for this. So therefore, number of possible structural isomer of this organic compound is how many here? 4. What are their names? First one is what? 1,1 dibromo propane up here. Propane. The other one is what? 1,2 dibromo propane. Are you with me? The next one is what? 1,3 dibromo propane. And the last one is what? 2,2 dibromo what? Propane. Okay. That is on that note. So there are 4 possible isomers for that organic compound. So this is not chain, but what? Position. But one thing with this and the one we did here is that both are structural what? Isomerism. The phenomenon. Structural isomerism. I'll give one more example, then I go to functional. One more example, I go to functional. Okay. So how many are there? Okay. Another example too. How many structural isomer? How many structural isomer are there How many structural isomers are there? Are there in an organic compound? In an organic compound. How many structural isomers are there in an organic compound? In an organic compound of molecular formula. In an organic compound of molecular formula C3, H, H8, O. How many? Okay, let me give you another way. So if the compound will confuse you like this, let me give you the condensed formula of that. So you know what we are looking at. This is supposed to be C3H7OH. I think it's better than this way than this way. But they can use any of this, so you should know. You should know. This is which formula is this one? Which type of formula is this? What type of formula? This is molecular formula. This is what? Molecular formula. What is this? Condensed formula. Condensed formula, molecular formula. In molecular formula, name molecular formula, it does look like all the atoms gather in one piece. Okay? Like how many all the carbon atoms? Can you see how where they are? 3. Okay, 3 H7OH. You bring it here, 8 and then O. This is what? Molecular formula. Condensed formula. Condensed formula can be written in many forms. I can see write it this way: CH3, CH2, okay, CH2 again, OH. Check if it's the same thing. Some way of condensed formula. If I now manage to now start writing the structure of this, like here now, or here, and say C1, 2, 1, 2, 3, H8. 1, 2, 3, 4, 5, 6, 7, 8. O, looking at how we look here. Here will be what? OH. Do you see? So where is the H7? Because I've used OH here. Look at this one. CH3, CH2, CH2, OH. Well, what am I writing? O what? H. Are you with me? Okay, I've corrected myself. Well, let's go again. CH3, CH2, CH2, OH. Do you get the point now? So this is, what formula is this one? Structural formula. Condensed formula. Molecular formula. Is that clear? Then, well, let's name this one. What name is given to this organic compound? Is what? Propan. Okay? No, wait. The OH is a functional group for alcohol. On which carbon atom is the OH? 1. This is 1. So it is propan 1 what? Or. Is that clear? So this is the first isomer. If I shift this functional group on this carbon chain, what will I have now? Propan 2. If I shift it to this one, will I have propan 3? It will still be propan 1. So how many possible isomers can you deduce from the organic compound? It's 2. It's not 3. It's 2. What are they? Propan 1 all and propan 2 all. Period. Please take down of it. Take note of it. 1, 2, 3. OH. Propan 2 all. So propan 2 all, propan 1 all are isomer of this organic what? Compound. Please take notes. Let me get one from Sure Guide. I cannot do this without getting one question from Sure Guide. It will be like, now that you have 1 month to go, this is the time to read Sure Guide more often. If you have not finished reading your if you have not covered your syllabus up to 80%. For any, let me tell you the simple truth. Any level, be honest to yourself. Any level you are now, maybe your syllabus, those jam syllabus, they are here. If you don't have jam syllabus, you can buy this and have syllabus. You can even buy because of the syllabus. I have not covered that syllabus up to 80%. I don't know how magic. I don't know how you're going to do the magic. Maybe you tell me after the exam. So get this now, see if you can cover the syllabus. I have the syllabus here with me. Uncle, get Akioxy from my school. Okay, I will do that for you. Some problem with some of you that write this, you write this kind of thing, send to the teacher. The teacher will just be moving in one kind of place to get to this place. Somebody just jump and starts writing rubbish. So I can get to Akioxy. You don't even understand this simple one. You're going to Akioxy. Oh, we come on tonton kakita. Choka onye wensubu. Okay, my name Akioxys. I tell you for Akioxy kete boss. Okay, let me use this question from JAM. Let it be that the questions are coming from inspiration. Okay, have another one here. We'll take this down. 1991 question. I think we all have this textbook now. And I said, go to page 305. All of you go to page 305. But you don't have it. Page 305. Page 305. 305 page. We're there. Anything. Just go to your writing material. Write those. Look at how you write something if you have your material complete. Now that it's on page 305, just go to that question, that small page you want to write the question. Just write page 305, private short guide, page 305, question number 20. You want me to give you a, so you go to another material and source it. All right. How many structural isomers? How many structural isomers? Happy by book. How many structural isomers can be written? How many structural isomers can be written? I repeat, can be written for the alkyl bromide. How many structural isomers can be written for the alkyl bromide? For the alkyl bromide. Alkyl bromide. Open bracket. Right, C4 H9 Br. C4 H9 Br. Option A 3. Option B 4. Option C 6. Option D 8. The formula is C4 H9 Br. The problem now is that the number is not the problem. The problem now is the name of the, if you say is 4 or 3, what are the names of those 3 isomers? Okay, well, let's see how many. For me, I may not know exactly how many the isomers are. I need to get down to find out by writing the structure. Okay? So you may not just guess correctly. Look at how to do it. You have to run it. They say C4 H9 what? Br. That's what they say. They even give you the formula. So what do you do? 1, 2, 3, 4. Abi? H9. 1, 2, 3, 4, 5, 6, 7, 8, 9. The what? Br. The first one is here. The first alkyl bromide is what? 1. The position must be stated for isomer. 1 hyphen bromo. 1 bromo what? Butane. The first one. If you don't rearrange, we have 1, 2, 3, 4. Now that is here, what do you have now? What do you have now? 2. So you have what? 2 bromo what? Butane. If you move it here, what will it be? Is it 3? Is what? 2. because you push it there or you shift it there, you had to count to give that bromine lowest number possible. So you cannot name from here. Okay? So that's the do you have the row. So what type of isomerism is this? Positional. How do you know it's positional? How do you know it's positional? Because the chains are the same. Only that the functional group are on different carbon what? Chain. They might ask again, how many structural isomer? They did not say how many positional isomer. So you will now have to now exhaust the possibility of what? Other forms of structural, which is what? Chain. You cut the chain. How many chain can I cut now? I cut the chain into what? 1, 2, 3. I can use this as what? CH what? 3. I can put bromine on any of this carbon. If I put this bromine here, it be what? It becomes what? Alphabetically. Don't say methyl bromine. No. Bromine will come first alphabetically before what? Methyl. So the name, the position they are, you must also state it. Which the two of them are in position what? 2. Which means the first one, which is bromo, is what? 2 bromo. You take a breather. You put another hyphen. 2 methyl. The long chain is what? Propane. Can this thing be enough for that compound? No. You have to start moving this around. You have to start moving this around. Either you move it here or move it here. So after you move it here, after moving it now, I think there can't be any movement again, Abi. You can't cut again, Abi. That is number of possible isomers, which is how many? 4. 4 is in the option, Abi. That's correct. But next question, the week is again, all the following are isomers of this compound except. There's another way the question can come. It may not come this way again. Say, all this, one, option A, option B, option C, option D, are all isomers of this except. You will see this one in the option. You see this one. You see this one. Maybe you see another one or when they get the answer. The question says, all the following are isomers of this compound, organic compound, except. That means you must know the isomer. Not knowing here is 4, is 5. You must know all the isomer that makes that particular organic compound, that number. Like in this case now, we know 1 bromobutane is an isomer. 2 bromine is an isomer. 2 bromo-2-methyl is an isomer. The last one, 1, 2, 3, CH3, and then what? Br. We also know that what? 1 bromo-2-methyl propane is also what? An isomer. So any other one that is not giving us any of this in the option is not the possible isomer for that what? Organic what? Compound. Photostat. That is it. Okay. And to functional group. If you are there, I'm there. Are we there? Yes, say what? Functional group isomerism. Or you say functional isomerism. They are the same. Functional group isomerism or functional isomerism. Okay. Functional isomerism, right. In functional isomerism, comma. In functional isomerism, comma. In functional isomerism. In functional isomerism, comma. The isomers have the same molecular formula. Have the same molecular formula. The isomers have the same molecular formula. The isomers have the same molecular formula, but different structural formula. But different structural formula. But different structural formula. But different structural formula due to presence. Due to presence. Due to presence of different functional group. Due to presence of different functional what? Group. Full stop. Full stop. Any compound, any isomers, when I say any isomers, any two or more compounds you see that have the same molecular formula but different structure, but then the isomers, the compounds, have different functional group, but they have the same molecular formula. That compounds or that molecules or that isomers are what? Functional isomers. Then the phenomenon is called what? Functional group what? Isomerism. Are you with me? Before I give an example, actually icon these structures here. You know, in these four structures of this compound, 1, 2, 3, 4. How we can get this structure in exam? If I'm to be an examiner, there are so many questions I can ask you from here. Too numerous questions I can ask you. In this particular compound, where both even having a structural isomer, we have chain, positional, and what? Functional. There are some isomers that may form chain and positional. Okay? There are some that may be positional and functional. You have to be very careful. If Jam want to go to extreme, to get extreme question from this kind of question, they want to go extreme. These are the things that they will use to manipulate your brain. Like in this form, in this compound now, this compound is, they say, what is the structural isomer of this organic compound? You see that the moment we did this and this, these two here are what? Positional. But you see this one, and this one, this one and this one, or this one and this one. These two, pair these two. What form of isomer is this two? It's chain. Do you know why it's chain? They don't have the same word, chain. They are not only chain, they are chain and at the same time positional. This is now bromine here, bromine here. Once the functional group change position, and the chain also change position. So in these two pair, in this pair of this isomer, these two isomers are what? Chain and what? Positional at the same time. Take notes. Calm down. I'm rushing. I can't understand. You are. It's not you are. Pleasure. What's this? Help me name this. So you've been that I did not see it very well. Name this thing for me. Daily. Calm down, Bukwageba. So excuse me. Am I too fast? Am I too fast? That I'm doing isomerism for two contactless. You must be stupid for those that say I'm too fast. You don't know what you're doing to yourself. Oh, you can't miscreants in this class. I'm too fast. You say you don't know, you don't have anything in your brain. That's why you are thinking I'm too fast. Some of you think you just come here, you want me to do miracle, you want me to make you understand. See, let me tell you, it will be a problem for all of you here to understand. Everybody cannot understand. So if you don't understand that, see yourself as one of those that can't understand is a natural thing. No, simple truth now. You can't understand. I don't know the background you are coming from. Probably you are coming from a background where you did not do this thing at all. If you come here, you can't understand. This is a penultimate level. This is not SS1 or where you will start foundation class. I am not running foundation class. I assume there are certain things you should know. So I'm standing on that principle. Not to come here and somebody will be telling you something I don't understand. You must be very stupid to say that. Or that you are joining the lesson just a few days. You're just meeting me for the first time. So I don't understand. You must be very stupid. Anybody, please, let me warn you for the last time. Anybody, in fact, I will trace you and I'll catch you. But I will write any nonsense that I read. As you say, I don't understand. I will look for you. I'll find you. I will check all your writing. Imagine with this. It'd be so stupid. This is just kulu him down. Water. That's why most of you see me. People see me as devil. People see me. People don't even like to see me again. That's why people don't like to. People don't like to. You prepare somebody that will come here and just be petty you, giving you. Do you understand? Okay. That's what you want. That's the kind of thing you want everything to be very simple. You don't want a very rugged, rigid. Just want everything to be spoon feed. I can spoon feed you. I will fox pin this. I don't know what I mean. That's why if I come here, that's why people disgrace me the last time. Disgrace me. You don't want me. I just enter class to teach you. Start saying no. People have to. They even have to just go and arrange me for another class. That's why people just want to finish my career. I'm not laughing though. I'm serious. And this is plan something. People planned it. You planned it because it's a planned deal. And this thing has never happened to me before. I come to a class like this, they say they don't want me. Maybe I'm a BML. I know the cause. The cause is because maybe that morning I was rushing. I didn't take my prayer serious that day. So the thing happened to me. Maybe it was maybe. Okay, please on a lighter note, on a more lighter note, please. You are not. There's no difference between teaching this level and then in a very less than few months you enter their side. See, you should be matured. The way they and we go lessons 1 and 2, about our thoughts. Please, why can't? Okay, let me reason this one. Oboro ibia class, you water or something. You the malisu. You man can say water, one water. To go. Oh, when Kim man you say water. In Kai you say water. When the water lay draw me and got gone. But over in Kai you say water, draw me a monkey, woman water. Monkey got water. How much I mean we experience. Very experience. We know the one you will know. We know the one you don't know. So we know the one that will confuse you. What is simple thing I'm doing here? I know why I did not want to add other isomers there because I know I'm going to be in trouble. If I add tautomerism here, metamerism, ring chain, I know I will explain. You know this thing, there's no evidence to even prove what I'm saying here. So that's why I just, for sake of my sanity, I just decided to cut those ones off and give you only 3. Those come just the question. And you could team na confusion. Because make it a can't withdrawn. It used to come out once in 20 years. They just bring the question. I pray that they will not ask that question. Because I'm not going to teach it because of the level. I will know that the people the merits, bear their own merits. I can calm down and bring out your equipment down in the class. Like what to bring. Some of you want to bring. Some of you want to bring. Some of you, all of you. Please, sir, why is this one? Be like, I don't understand. Before I read your this, you must put down your name, put your phone number. Where's him, sir? Please, why can't Odenka be like this? Or why can't it form another isomer? it cannot form another isomer because you can no longer cut the chain beyond 3. Okay? I've cleaned it. You cannot cut it beyond what? 3. And the number of carbon atoms is how many? Was 4, Abi. You had cut it to 3. And you cannot cut it beyond 3. If I cut it beyond 3, that means it will be 2. So there won't be any free carbon to start adding those cut and join. You cut, you join. You cut, you join. That's isomerism. Cut and join. That's why. And to why this one will not be like this? How can this thing be like this? Do they have the same number of carbon atoms now? No, now. How many carbon here? 4. And now what's the isomer again? Because this one is what? C4. 1, 2, 3, 4, 5. C what? 5. They are no longer isomers. I don't know where you get this one from. And when you polygraph and can have here, 1, 2, 3, 4, 5. 2 bromopentane. That is what you are giving me. But you are giving what? C4. H9Br. You increase your own to 5. Foolishly. Only tell you, I'm not going to go. Nanka de re. Na yenga funding age this kind of thing. And on a booklets. Nga mu de giga fia. I'll go around. Oya gonna chokoketa gozo na bi. Is there many formula to find Is there many formula to find how many structural isomers are? So let me tell you a simple truth. There are no formulas. There are no formulas. Even the so-called formula that they try to use to manipulate, that one can only be for chain. You know what I mean by chain? That one can only be for chain. But once structure is changing because position of functional group are changing, you cannot get it with formula. The only formula to get it is by writing it and find out if there any possibility of pushing it here, and see you can no longer push it again. You now count to see how many isomers that you have formed. You write it down. So that is the only formula. So there is no formula, arithmetic formula that you now solve and get the answer for. No, that one cannot happen. But it can only happen for chain. Let me give you an instance. Open now where you can C4, H words, 10. Yes. How many chain isomers are here? Imagine just know how many chain isomers. This structural isomer can only form only chain. Or not form position. It cannot form functional. Okay? It cannot form functional. The only isomer form of this organic compound is what? Is chain. So now that I know it's chain, I can use formula to know how many possible isomers. And that formula is what? 2n, 2 our exponents. N minus 4 plus 1. That is the only truth for this. But watch here now. Where this N here is number of carbon atom. If the carbon atom is 20, you say 2. Now that the carbon atom is what? 4. You put 4 minus 4 plus 1. Which is what? 2 raised to power what? 0 plus 1. 2 raised to power 0 is what? 1. 1 plus 1. The possible isomer of that organic compound is what? Is 2. I didn't make it before. But don't try it with this one. If you try with this one, Wagner. If you try it here now, it will give you what? 2. But let me ask you, how many possible isomers are there in this organic compound? Is how many? It's 3. But this nonsense will give you how many? 2. You just go and fill it. Do you know why? Because this one will not only give you chain, it will give you both chain and what? Position. Why? This one is an alkene. Can I say if here 1, 2, 3, 4. Towards the 8, talk about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you go opposite these 2. Okay, this show no way go double bond. Go to 8. If you like it. So this is what? Put 1 in, Abi. You will shift it. It becomes, so it means put 1 in and put 2 in. What type of isomers are they? Are what? Positioner. The functional group is double bond, Abi. Now is in position 1. If I shift it here, it becomes what? But what? 2. How many do we have now? But 1, but 2. The 2 are positional isomer. Where it can also form chain because it has how many chain? 4. So chain you can't have anything less than 3. So it's 4. You can cut. If you cut, you can have 1, 2, 3, and then what? 4. You can put the bond somewhere here. It's safe. That is the third one, Abi. If you put it here, it's the same thing. Sure, you know now. What is the name of this one? 2-methyl prop 1 in. If you push it here, 2-methyl prop 1 in. We go with but 1 in. It will go with but 2 in plus here. How many possible isomers are there in butane? 3. How many are there in butane? 2. So that is why the formula is only this way. So any other formula you are doing, you must be very careful to know that it is for alkanes, chain alkanes. We follow that isomer. So open now go know alkanes in a functional group. Now man way possibility of their functional group moving from one carbon to the other carbon. That means and the only thing that changes is the chain of the chain length. Chain length is long, is short, is shorter, is shortest. You know that kind of thing. Then I can use this formula. This formula works perfectly. It will work to some extent. But the way it will not work. It will work from 4 to 10. But any organic compound above 10 carbon atom, it will no longer work. But mind you, examiner will not go beyond 5 carbon atom. Go and check it. How many carbon atom? 5 carbon atom. Or let me say, they can go beyond 6 carbon atom. I've seen 6. How many possible isomers are there in C6H14? How many possible isomers are here? Use this formula so we don't waste time. How many? 5. Use the formula now. So what do you have here? 6. 6 minus 4, 2. This is 4 plus 1, 5. How many get 5? When check it and get a short guy, I show you the. But open email hexane. Oburi hexane hexane formula. Formula is meant to solve all problems. So any problem that you cannot solve, the formula omanga tizaka now. You see, that means the formula can only solve the particular peculiar issues, but fail to solve that same issues in another form. The formula is not acceptable. So know the limit to which you can use the formula and limit where it cannot work. In fact, let me tell you this, to be on the safe side, don't even use the formula. So you don't go and see butane and use it for butane. They will know that you use it. They will put the answer 2, 3, 4, 5. And you use it, the answer will be 2 if you use it. Why the answer is what? 3. Why did you say that this is chain? Why is position isomer? Explain. Yeah. Why did you say this one is this one, this one is this one? See, listen to me. Onye Daleya. I said that. There's that structure. Can check here. Which one is that one? This one. And this one. Okay. You can't cancel off. You're wasting your time. Okay. Time you get your carbohydrate, protein, fat, and oils, alcohols. You are here. Want to die in isomerism. That only one question may or may not come out. If you watch proper celantephalon. You know what is celantephalon? Celantephalon means cerebral hemisphere. Do you know what is cerebral hemisphere? It means cerebrum. Do you know what is cerebrum? You don't know, it means brain. Let me come down to you. You don't have a proper rhombocephalon, telencephalon, and what do you call the last cephalon? You of course, it's all the 3. Forebrain, midbrain, hindbrain. Come over here, Joe. Oh yes, no 1, 2, 3, 4. Somebody please should refill my marker. See, your question, it ain't. Or even if you are listening, you don't have high quotient rule to understand. Why do you say that that this is chain? Why it is positional? I said that this is chain. This is also what? Positional. At the same time. Isn't that what I said? When you emoji chain, you made the both chain, the two of them are not the same word. Chain. Can you see? Chain length here is what? 3. Chain length here is what? 4. So the two are chain. And at the same time, the two are positional. Why? The functional group here and this one, are they on the same carbon chain? No. So these two structures are both chain and what? Positional. Oh, you didn't call before, but in all, maybe something is distracting you. I said it, you did not get it. Okay. Uncle, please, I thought. Thoughting. Hey, onye abufte formula also. Ni calculation here. C3, this guy must be an engineering. He's supposed to be in engineering class. C3, H6, BR2. Niyo remember. Otinya reba pianka 6. Tinya reba pianka 2. Melomeya. Same equals to 4. Therefore, the isomer is 4. Omejesisim, thank you, sir. The young man just taught me something. I don't even know. If you try it again, well, let's try. It may be true. Well, let's try you. Let's try. This guy is intelligent. C2. This guy is intelligent. C2. Let's check it here. Oh, what's here? Man needs you. You man like question the wow who's. But oh, you tell them gone. C2, H5, Cl2. Okay. Ke masa holo kita. Kailonian. Hey, onya the bad. 5. Hey, 2. And is what? 3. Hey! Somebody should tell me, how many isomers are there? How many isomers? How many possible isomers will be there? It's 2. Neno. 1, 2. 1, 2, 3, 4, 5. Okay. I made to do a mistake. Hey. Chalo. Wait now. I'm gonna wait. Wait now. I'm gonna wait. Mba, nke bụ ndị dị too mild. You want to go? Oh, the mild. Ngwa chalo. No. Wenu ndidi. C3 H cause ambode 8 O1 so O cello now who now was that speed. Can you question and the correct? I got the correct, okay? Then 1 2 3 1 2 3 4 5 6 7 8. Then okay? 1 2 3 4 5 6 7 OH. Oh yeah, now. Okay, men can walk. You want to know that quack because can't walk. Okay, check it. Give me here now. Give me here 8. Give me here 1. How many? 7. So so 7. This one is not propan 1 and propan 2 all. How many isomers are there? 2. That no walk, no mistake walk wherever. No, so very mistake come and walk here. Total mistake come and walk here. Walk on cause. It's still like a walk and ending cause. Only you can make a formula walk on this thing. So far, it is what? Positional. It will not work. But I must commend you for this. For it to work in C3 and C2. C3 and C2 of halides. If we're going to make C3 of alcohol, alcohol or work. Email and kaketa or working and where. But in don't tie teacher, kita wiki walk. We kill walk. But we come out walk from C4. May look at C4. Kita not get way more now. C4 1. Maybe I have 4 of these. 1, 2, 3, 4. Then I have Cl, okay, I have one Cl. And you are asked how many. It will not still work here. Okay? Because I'm only 1, 2, you break it. Okay, why you the same thing, which is how many? 4. Because of here, I'm here. I'm going to try it to see if it will work there. Now, let's try it. 9 minus 1 is what? 8. Okay, work, but in work and work, it's not just two things that work. Does not give it, does not make this generally what? Acceptable. But it's good that you know all of this. It's very good. I think it worked. I didn't even know it would work in C2. If I had known it would work in C2 in this one, I wouldn't have given it as an example because I actually know where I'm not when actually where I'm not gonna work here. I did not know. I did not check it very well. See, very simple to see. 4. When you go get 2, you are trying. You are doing well. So please, maybe you don't get bigger. Call again. Please don't use it. Anything that cannot go as in can't be all inclusive. Please never use it as something that is generally accepted. Please, with the formula, are you good to go in finding isomers from 1 to 3? No. Isomer from C1, most especially those of alkane. Alkane is amawu isomer. The isomer of methane is self. Enable self. Methane isomer is self, which that drug isomer is 1. Ethane isomer is what? 1. Propane isomer is what? 1. The number of carbon atoms should not be less than what? 3. I am propane the 3. So it's a cut what chain ki wanted to or ma more cause. Every isomer bido bonagini butane. Why? How many carbon atoms are there in butane? 4. So it can cut and join. After that first cutting and join, it cannot cut again. So once you leave it straight, it forms one name. Once you cut and join, it forms 2 names. And there is no more cutting and joining. So how many isomers can it form? 2. If you straight it to 5, first cut and join will give you 4, remaining from 5 to 4. Next cut and join will block it that side. It's now 3. You can't cut and join again. And you cannot shift the alkyl group from one place to another. So how many isomers will it give you now? 3. And so on and so on. 4. As the carbon atom is increasing significantly, isomers, number of isomers is also what? Increasing. Okay, I've answered you. But meanwhile, for those of you that will still insist that the formula can work, they want to be using the formula. Please never use your formula beyond C4 to 7. That is from butane. Make sure you stop at what? Heptane. The formula C2N minus 4 plus. This formula can only be used for what? C4 to what? C7. Once it goes beyond C7, it will not work. What will work for 7 and 8 alone? 7 to 9, not to 8. 7 to what? 9. Sorry, 8 and 9. So the only one that can work for 8 and 9 is here. Will be what? Plus 2. It's formula that just do like this, although consistent. You can't use it now. If although consistent, you wouldn't have, if you have managed all of them. Then C10 does not even, you just add the other one from A to Z. Or yeah, KBL. So please, the formula is fake. So try C4. I'm not trying anything. Okay, I'll try and come on, work. I'll try go me. I think you see. Okay, let's go to functional isomerism. Please, fast. Functional isomerism. Functional isomerism. Is it? I didn't get you. Okay, they get before. No, I can place an example of where? Examples also. Number one. One. Alcohol also. And ethers. Look at the ether, not ester. Alcohols, and ethers are functional group isomers. Alcohols and ethers are functional group isomers. Example. Ethanol, or ethanol or ethyl alcohol. Ethanol or ethyl alcohol and dimethyl ether and dimethyl ether and dimethyl ether and dimethyl ether are functional isomers, are functional group isomers. Ethanol or ethyl alcohol and dimethyl ether are what? Functional group what? Isomer. Well, let's draw the two structures to see why they are isomers and what makes them functional group isomers. Let's draw the ethanol. Ethanol is what? 1,2,C2 H what? 5 O what? H. This is ethanol. Whose molecular formula is what? C2 H what? H what? 6 O what? 1. That's the formula. That's the molecular formula. If you say C2H5OH, that is condensed formula. I say that now isomers are molecules that have the same molecular formula. They say the same condensed formula. This is the same molecular what? Formula. So this is the molecular formula for alcohols. Y C2H5OH or CH3CHOH. These two are what? Condensed formula. This is the actual molecular formula of this. Well, let's see the other one. The functional group is this, Akuya. Abi? This is what? Functional. Functional group of what? Alcohol. If you have OH. Do you see? So over here you have COC. At this side, you have CH3. At this side, you have CH3. Okay. I have a question, but before that question, I would like to give you example 2. Example 2. Can someone here tell us another isomer, apart from the one I just said now? Another isomer that you can refer to as functional, as another isomer that have different functional group, but the isomer. Which one? Alkanals and alkanones. Very correct. Well, let's start number 2 now. Number 2. Alkanals and alkanones. Alkanals and alkanones. Alkanals and the alkanones are functional. Alkanals and alkanones are functional group. Alkanals and alkanones are functional group isomers. Are functional group isomers. Example. Propanal and propanone. Example. Propanal and propanone. Example. Propanal and propanone, comma, glucose and fructose, etc. Example, propanals and propanone, propanal and propanone, comma, fructose and glucose. Fructose and what? Glucose. Okay, now look at the functional group. The functional group for alkanal is what? CHO. CH what? O. The functional group of alkanones is what? Like carbon monoxide. Like carbon what? Monoxide. So if you see this group like this, CHO, This is what? Acanal. Any compound that have it as carbon 1 is an acanal. If you see CO, anyone that has it is what? Acanones. Take note of this. Very important. Acanals, acanones. Okay, if I have this RCHO, that is the general formula. If I have RCOR, that is general formula. R is the alkyl. What if the R is C2, is 2C, is C2H5, CHO, condensed formula? How will I write the molecular formula? C do never C3, H only 6, O only 1. Okay? So umbia nanka kata menka CH3. Okay? This C O. Do you see? And what? CH3. Do you see? So now, if I want to write the condensed formula, what will it be? Sorry, molecular formula. C3H6 and what? O. If we now have the same molecular what? Formula, different what? Structure. Is this, see, the structure is not the same. The same. This one is what? The same. The same. Why this one is what? Different. Are you with me? As well as the functional what? Group, which is also what? Different. Are you following? We can convert. Yeah. Okay. If we not convert to go to something, what name is given to this first one? For having this is what? Propanal. And this is what? Propan. Can say it's propanone or propantuone. You change the position of the own. Yeah, position 1, 2, 3. Or what? Propan what? 2 what? One. That 2 one look like ONE1, but it is called one here. So you see, the same thing with sugars. For example, now C6H12O6 is what? Glucose. C6H12O6 is what? Fructose. But if you draw the structure now, you now see structural changes. You will see CO for fructose. You will see CHO for what? Glucose. Okay. Then to the question. Okay. Now this one say, just your ear, just let me your ears. Which of the following are structural isomers? A. Propanoic acid and propan 1,2-diol. A. Propanoic acid and propan 1,2-diol. B. Ethanoic acid and propanoic acid. Ethanoic and propanoic acid. That is, which one is structural isomer? You know, structural isomer means it can be chain, it can be position, it can be what? Functional. Good. 3. Ethan 1,2-diol and ethanoic acid. And D. Propanal and propanone. The answer is what? Propanal and propanone. Or ethanal and ethanone. And by what ethanone? Sorry. Or butanal and what? Butanone. A word ethanone. Remember ethanone. The carbon here must be second carbon atom. So if you say eta, there is no second carbon atom. Okay, another RCOR. Okay, we two alkyl. Ethan we only one alkyl. Can I say CH3, CO. It doesn't work like that. So the CO must be at the middle between this and what? This. So the simplest acanone is what? Propanone. The first member of acanone is what? Propanone. No methanone, no ethanone. The first is propanone. Please take notes. It's very important. Okay. Finally, number 3, the third example. Third example of functional. Right. Give me now. Please, you said that this as isomer, but you forgot to add this one. Okay. He said that CH3CH7 has isomer of 2. Yes. See, why I will forget to say that is because are you there? Why I will forget to say this is because probably any isomer that decide to go different from functional, any isomer that is not the same functional group, we don't consider it as one of the main isomer of a compound. Like for instance, C3H7OH is what? Is a functional isomer. We come from here, go to an ether. Do you understand me now? We come from here, go to an ether. Know that an ether is what? Is an isomer that has different functional group with what? Alcohol. So whenever you are writing a functional group isomer for alcohol, make sure that the alcohols, the isomers conforms with the same functional what? Group. Please take notes. Now this question, they know how to ask you the question. If they want to ask you a question on isomer that belongs to different functional group, they will now come up clearly, okay, to now say how many functional. They will now be specific, or which of the following pairs are structural isomer. They will give you the one that will merge. So I cannot come now and add this one you gave me here, which is methyl ethyl, adding it to what I've given you before as propanol. I told the propanol has how many isomers? 2. I cannot come and add this one except it is specified in the question. They must specify it. They must do what? Specify it. Let me also shock you, another shocker. Do you know that cycloalkane and alkenes are isomer? Which type of isomer? Functional. But let me show you something. And again, I cannot, because of that, now start adding it to this list of the isomers of alkenes or the list of isomers of cycloalkenes. Okay, let me show you something. Supposing I have, what do you call this? 1, 2, 3, 4. Abi? What is this? C4H8. Check it very well. Which is what? Butene aquia. I know it's but one, but I'm not mindful of that. They have 1, 2, 3, 4, 5. Give every carbon 4 bonds. This I've got 4 bonds, 4 bonds, 4 bonds, 4 bonds. What name is given to this? Let's check it. How many carbon is here? C4, 1, 2, 3, 4, 5, 6, 7, 8. H8. It's isomer. The two are isomers. Well, let's see. But if I want to name this, what's the name? He put cyclo, cyclo what? Butane. I took an exam. Here can you get back? How much you ideal butane onion cast isomer? How can you get butane and cyclobutane are dash? Now, butane belongs to functional group of what? Alkene. Carbon double bond. You can see it now. Then this one belongs to what? Carbon what? Single bond, which is what? Alkane. So the two are what? Functional group what? Isomer. But you will not add it to the list of isomer of butane. You cannot even add cyclobutane as part of what? Isomer of butane. You can't do that. So add these two again as example 3 for functional isomerism. Add it there, example 3. Butane and cyclobutane, or alkene and alkenes. They are at one point, but one are those of cycloalkenes. Okay, number 4 example, the last one. Alkanoic acid. Example 4. Alkanoic acid, and alkanoic acid and alkanoids or ester. Alkanoic acid and alkanoids or esters are functional group isomers. Are functional group isomers. Are functional group isomers. Example. 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 Butanoic acid. Butanoic acid. Butanoic acid. And ethyl ethanoids. And ethyl ethanoids. And ethyl ethanoids are functional group isomers. Are functional group isomer, please, no isomers. Ethyl ethanoids and butanoic acid, or butanoic acid and ethyl ethanoids are functional group what? Isomer. Are functional group what? Isomer. Well, let's see the two here. One we have COOH. Happy? One we have what? COO. COO is alkanoids. This one is what? This one is what? Now, this one, this one, what in your you get in arrow here, tinye arrow here. Which one is this? Alkanoids. This one, alkanoic acid. What is the CH3? Okay, that's the butanoic acid. How many C got in an arrow for butanoic acid? It's not 4, it's 3. 3 plus this one is 4. So it will be CH3, CH2, CH2, COOH, or C1, 2, 3, 4, C4, 3 plus 2, 5, 6, 7, 8, H8O. See what? C3. Count now. 1, 2, 3, 4. H how many? 3, 4, 5, 6, 7, 8. O how many? 2. 1, 2. Do you see? Do you see? Okay, well, let's come over to this side. What if this one is what? Is what? CH3. CH3 is alkyl. CH3. COO. What if this one is what? C2H what? 5. Is this see? Do you see the structure? It says structure. Say the structure. Can give code. Give no bozufu. CH3, CH2, CH2, COOH. If you do you see? Oh, fear now with this one. No. Go and circle functional group. Circle this one. Circle this one. This one is what? Butanoic what? Acid. Okay? This one is what? You know when you don't want to name an ester, you start from the last alkyl of alcohol. You know how this is formed? Normally, Onya, if RCOOH react with ROH, do you know this reaction? This is alkanoic acid, okay? This is alkanol, okay? What the reaction going forward? What do you call it? Boy, normally it's supposed to be called condensation. It's condensation. It is not it's because it form an ester. That's why it is esterification. What the main name is? Why that get changed one day? You make a wrong thing. One day they will change to writing. The right reaction is do you know why it's condensation? Because the reaction eliminates a molecule of water. Look at it. Look at it. Eliminated. What is remaining? RCOOR plus what? H2O. That's why the reverse reaction is what? Hydrolysis. These acids. The reverse reaction of esterification is called what? Hydrolysis. Why the fourth reaction is called what? condensation. Period. What if this thing now is this thing? Is this one? And this one is C2H5OH. And this one is, how will I put it? So C3. If I have C3, this is C3H7. You know this is propene now, isn't it? It's propene. Is it C3? It's supposed to be okay. C2. Quoi? Is it F C2? I don't want to. Okay. Well now. Ethanoic acid. Ethanoic acid will be what? CH3. Okay. Then C1, COOH. What are the two? What are you having? Open milli. Sea water. Okay. Up go now. What do you have? CH3, COO, C2, H5 plus what? H2O. If you want to name this ester, name the alkyl of alcohol first. Do you know me now? Name the alkyl. Which alkyl is that of alcohol? Yeah, alcohol. Like, yeah? Nka be ni sia jeba about the alcohol. Nka neba kita about the ethanoic acid. Yeah? Good. If you want to name it, it will be what? This alkyl is from alcohol. What is this alkyl? Is what? Ethyl. Ik pogon kete je posi nka. Ichi pon kika pokonia with nka. And this thing has changed from COOH to what? COO. The ending of this one is what? OH. Check the jumbo pack. You will see it. I just circled it and put it that to remind you of something. Buy the book and know why it is there. Circled. I can know it. So that means if it must end, it will end with what? OATE. So it is ethyl guinea. 2 is proper. Now here, put OH. So ethyl, sorry. 2 is what? Ethane. Change the oic before to what? OH. So what was it? Ethyl what? Ethane. OATE. Are you with me? So the name is ethyl 1,2 ethanoate. Then ethane is 2. Methanoate. Do you get the point now? So check if the 2 are isomers. Check. This one has what? 1, 2, 3, 4. C4. 1, 2, 3, 4, 5, 6, 7, 8. H8. This. Let's check this one. How many carbon is here? 1, 2, 3, 4. C4. H8 is how many? 3. 3 plus 5. H8. How many O's are there? O2. So the 2 are isomers. They are isomers. But what form of isomer is this? Functional group. Period. Take notes. Yes? Period. Okay. Done. Do you still have capacity to stay long? Man, you can go nurses. You can go nurses. You can go the room. You can go. I don't know some of you. Okay, I have something similar to what we just did now. If you have jam prep, jam pack, and I say you should go to page 308, still on that page, you will see a lot of questions. This one is exactly what we just did. 2012, number 60, page 308. They say the isomers of C3H8O. It's still even on the board. The isomers of C3H8O. That is the question. Is dash. Please take it down and give me the answer. The isomers of C3H8O are dash. I did just call just 3 words. And you're telling me to wait. Page 308, number 60, year 212. The isomers of C3H8O are dash. Answer is what? A is 1 propanol and 2 propanol. B, 1 propanol and 1 propanol. C, 2 propanol and 2 propanol. D, 2 propanol and 1 propanol. The answer is what? Answer cannot be A. You have to check very well. Propanol. Check the molecular formula of propanol. Check, okay, check. Can you do question? Are you confused? How many carbon atoms are there in propanol? OH8, OH8, and O1. The answer is A. 1 propanol and 2 propanol. The answer they gave here contradicts my own position. So it's one of the small errors, okay? You know why I said if somebody will just go there and just say, but the answer here is D. And you come and worry me. It's just one of those typographic errors. You know what I mean? So make the correction. The answer is what? But you know, typographic error, maybe give somebody to write A for you. The person decided to just go for D. You know, maybe the person might have taken 1 or 2 bottles. You know, the question is on alcohol. So the person may have taken alcohol, so the thing would have been the effect. So here, I just checked the answer here. The answer here is D. You don't understand me. Is it A here? Okay, man. Okay, they say A. Okay, man, number 60 again. Okay, see, no, 63. Okay, 63 na 60 bofi. I can check 63. Okay, bofi, but how would you answer? How would a C3H8O? I think you know how to run empirical and molecular formula, because I'm not teaching you that one. It's too simple. Well, if you insist, maybe next class I just solve 1 or 2 examples and give you technique. Oh, there's some other complex way to solve. There's so many complexity in empirical, so don't think you know it. Okay. Finally, I would like you. You know, I'm not used to giving assignments. I want to give assignments to stereoisomerism. Please read this topic. And what I'm saying, you should read the topic. In your textbook, it's not even up to 1 page. Read it and read it to understand word to word. So next time, I will just give you examples. What I'll just do here, I'll just give you examples why some compounds form geometric structures. And only geometric structure can only occur in alkenes. It is not feasible in alkanes. You know why? I'll just tell you, but I want you to go and read it first. Okay? The same thing with what? Optical. Read optical and non-optical compound. Compound that rotate plane polarization of a plane polarized light. Go and read this. Compound that are enantiomeric and diastomeric. Compound that are superimposable and those that are non-super what? Imposable. Compound that are mirror image and those that are not what? Mirror what? Image. Why do we have D-glucose and L-glucose? What does D means? D means dextro-rotatory and L means lavo-rotatory. Just go carry over there. In the next time, 30 minutes, I'm done with it. So I can enter another level of carbohydrates, another organic chemistry too. Carbohydrate, proteins, amines, amides. Are you with me? Because no time. I think added junction. Please, it's not added junction. I used to say it before. Nobody corrected me. Sir. Please clarify me. Percentage of nitrogen in urea. Okay, they will give you. Please, when you mean urea, ask the percentage of nitrogen in urea. Urea is, you even give me the formula. See? It shows this is correct. I don't know if this urea, your own urea is correct. Urea could say both C, okay, O dear, okay, it's correct. They will give you bracket C, 12, H, 1, N, 14, O, 16. How many N is here? 2. Say 2 N over molar mass of this times 100 over what? 1. You get the percentage. That is your question. Yes, next question. Yes. The one we just did now is from the short guide. Is it from the short guide? It's from my short guide. Okay, go ahead. Propanol. 1 propanol and 2. Good. No. 1 propanol and 2 propanol. 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 Push 1 to 1. Push the other one to what? 2. The compound form how many possible isomers? 2. Propan 1. But the jump sometimes they make and this in it's not supposed to be called 1 propanol. It was propan 1 all, propan 2 all. I did the way 2 niru before the name. So that is in the bottle. What is a propan 1 all? It's same as what? 1 propanol. That is a propanol that have OH at what? Position 1 of the carbon skeleton. In the absence of no other question, I think I have to call it what? It did.